All right. Yeah, can you hear me okay? Yeah, finally. All right, so I'm Sheng. I'm from Rancher Labs, and today my topic is enabling stateful workload across clusters. As you might know, one of the defining features of Rancher 2.0 is the multi-cluster management. And when it was released about 2 years ago, it's really have a little bit of debate across that if we go to multiple Kubernetes cluster or go to the federation. I don't think nobody has that question now. But what's the status of, say, the Kubernetes users regarding the multi-cluster management? And recently, Rancher Lab has sent out an industrial survey and get some interesting result. So we found out that about 91% of the users we surveyed are already running multiple clusters. And of course, it's with or without the Rancher. But in fact, even for the remaining 9% of users, 46% of them is planning to run multi-cluster in the next 6 months. You can see that it's really encouraging trend to be like rather than have a very huge flat Kubernetes cluster with thousands of nodes, it makes more sense to divide them into multiple clusters and have them function as different functionalities and provides their contribution to a service. So there are few types of usage for the multiple clusters. The one is, of course, you can define your production cluster, your developer cluster, your test clusters, or your cluster running different services. That's definitely one. Another one is you are going to say that if you want to have a cross-cluster disaster recovery, like that one cluster in one data center is down due to some unforeseen outage, and the other cluster should very quickly pick the service up and get every service back online. That is the one thing we want to talk about today, because it's all about storage. And the multi-cluster for the DR purpose on the storage part is hard. And I think it's a lot of many speakers before me already mentioned that, but I just want to emphasize that why it's so challenging to do the multi-cluster disaster recovery. It's most likely because of the high latency of the network, making it impossible for you to replicate data synchronously across the region. And another one is like you probably can have a multiple cloud provider or even on-premise or the cloud with the cloud. And of course, they're all running Kubernetes, but from application, they don't really feel the difference. But from the operation point of view, if you are using the different infrastructure support your Kubernetes, you're going to have some problems to just say that we should use this backup cluster, which is probably going to have a different storage system than the main cluster, and the data migration will be a problem. So all of this resulting in a more challenging environment, especially for the stateful workload, because you know that the data is not really easily moved. So I talked with our field engineers, and we see that in the reality, with user deploying multi-clusters for the DR purpose, there's basically two models. One model, we call it active-active, is basically just rely on the application's capability to provide global geographic redundancy. Like MongoDB and Cassandra, they do have this kind of support, at least in their commercial supports. And in the Kubernetes, you can choose, say, to program your own network endpoint, or you can use some software project to provide the connectivity across the clusters. For example, the Rancher Submariner. Submariner is the new project Rancher just created, and it's just to connect to two or multiple Kubernetes clusters and make the pod inside them able to access others' IP and the service, even in the different regions. There's, of course, a very good advantage for this approach is because the failover is building in your database or data store application, the failover will be very fast. But of course, your workload must support geographical redundancy for this to work. And sometimes the cross-cluster network setup can be very tricky. And then not to mention that you probably need to have actual commercial support or the feature support to enable that feature in your applications. Another approach we see that is what we call the active-passive. So this is a more general approach, like the stateful workload doesn't really have the geographic redundancy support, and you can go with this approach. What this basically is, an essential many speakers before me demoed is you're going to utilize the storage capability to replicate the data to the backup store, to the backup cluster. For example, the CNCF Longhorn. So I was a little bit attempting to say Rancher Longhorn, but we in fact just donated the project to the CNCF last month, and now Longhorn is a sandbox project in the CNCF. So for this approach, we basically support all kinds of applications. There's no limitation and which one you can apply or not. But the downtime can be longer, and if you're not configured in the fully automatic way. But in fact, it's more practical use cases for the most of the applications. So in this talk, I will going to demo you the CNCF Longhorn. The Longhorn is a project the Rancher Lab has started in fact, in 2014. It has been a very long time. But finally, we make it into CNCF, and we have just announced the 0.7 release, the first beta release of Longhorn last week. And the Longhorn is a completely open source, not open core or whatever other variety of open source. It's completely open sourced distributed block storage software for Kubernetes. You can find more information at longhorn.io. And now I'm going to demo that how you can achieve the disaster recovery in the active passive mode with Longhorn. Yeah. So here, what you see is the Rancher setup contains 3 clusters. I'm going to use 2 of them for today's demo. And one you can see that's called the demo, another one called the demo 2. So the first step is I'm going to install Longhorn. I select demo, and I select the storage project. And in the app, I'm going to launch. I just found Longhorn. And I don't need to really configure anything. I click launch. That's it. And in the workload, we can see that the things starting going on. And you can see that the UI is already ready, and the manager has been deploying. And there's one thing called the Longhorn driver deployer, which is the component we use to deploy CSI or flex volume. But now we starting Longhorn, the latest beta release, with supporting CSI 1.1, and that is the only protocol we support for the driver of Kubernetes. So other components are deploying. Yeah, seems everything's running. Let's go back to the app. And that is how quick you can get the Longhorn installed. And now you are looking at the Longhorn UI. So in the dashboard, it's very easy to see that on the left side is how many volumes you have, what the status of them. At the middle is what the storage you have, and the right side is how many nodes you have, and some details in later. You're probably wondering where this storage coming from. So basically, by default, Longhorn installation, it going to use your var lib rancher Longhorn directory on your root to provide the storage for Longhorn. Of course, that is customizable. And we are going to remove the rancher part from that because now it's a CNCF. So on the node page, you can see that we have 3 nodes available, and each of them has 1 disk. You can easily see the node. You can enable, disable the scheduling for the node, and you can see that this is a default disk, which is at var lib rancher Longhorn at the moment, and what's the storage available and the storage maximum. And if you want to add a new disk, you click Add. And in order to add a new disk, you just need to get the block device mounted on your node, and give the Longhorn its path. Put it here, and Longhorn will recognize it. So on the volume page, I don't think there's anything going on because we haven't used it. It's just reading stored. On the backup page, yeah, you see an arrow, but that's intended. So the backup is the place Longhorn make the backup of the volume. We call it the backup store. In order to use it, you can configure it in the settings. Just set a backup target and the secret. So the target can be an NFS or S3, and the secret contains the access key, the secret key, and endpoint to that S3, or in fact, it's just S3. And its Kubernetes secret is you don't need to just type it into the UI, so let's save it. And go back to the backup. It's taking a little bit longer than I expected. I think I get a network issue. Sorry, I think I get a network issue. Yeah, everything looks fine. Oh, OK, finally. Yeah, that's a bit scary. And you can see here is the backup showing up from what we previously has backup into the S3. And now we are going to start using it. Oh, seriously? OK. Let's just pretend we haven't seen that. I'm now at the default namespace of default project of Rancher. I'm going to start the WordPress to use Longhorn volume. To use the Longhorn system we just installed. So this is a standard WordPress. And select the Longhorn as storage class. This is key to connect Kubernetes to Longhorn. And let's launch it. OK, now Kubernetes is starting to talk to Longhorn and provision the volumes. I think there's something with the network. So you can see that on the right side, the downside, this one should be green, and this is WebSocket. And somehow I get arrows here. So that's why I kind of need to manually refresh to get the latest result. So you can see that 2 volumes has been created, and they are in the attaching stage. I bet if I refresh again, yeah, they are mounted and healthy right now. OK, so WordPress has been created. And during the time, let's just take a look at how the volume looks like. So here, you can see the volume name, the size, and when it's created, and the information regarding who is the workload using this volume, like PV and PVC name, and the namespace, and the pod. You can see, OK, this workload, which is the replica set, which of course is deployment, is using this volume. And the pod name is WordPress-6067, whatever. And all this information is we get from Kubernetes and help you to manage your volumes and knowing which one you are dealing with right behind. So when you click the volume name, on the left side, you can see the detailed state and the health, and which node is attached to, and what's the block device we create on that node to make it possible for you to use, and the size, the accurate size of Longhorn, how much space Longhorn has taken. On the right side, you see that we have 3 replicas. And if you want to know more about how Longhorn works, welcome to join my Wednesday session in the afternoon. I will talk about the introduction to Longhorn. So down here, we can see the snapshot. And also, you can create backup as well. And here we can schedule the recurring snapshot and backup. So let's do it now. I can want to, just for the demo purpose, I want to make a backup every minute. And I want to return last 5 of them. Just click Save. OK, so now I see that this icon lit up. So that means that, OK, this volume has been backed up properly. And it's for the WordPress. Another one is for MariaDB. I'm going to do the same for it. Just want to set up backup every minute. Retain last 5. OK. By this moment, I think the WordPress should be ready. Let's refresh it. Somehow the WebSocket doesn't work. All right. So WordPress is up. And this WordPress, all the content of this WordPress is backing up by the Longhorn. So we can just make a few simple posts. OK. Let's just create new post. Longhorn CSS demo and publish it. View post. And head back. Yeah, everything seems working. And what if that I want to have a backup cluster for this WordPress? So this is coming with the demo 2. And this is totally another cluster. It's not in WebSocket always complains, all right? This totally demo 2 is in the other clusters. And I already have the Longhorn system installed in the demo 2 cluster. What is wrong with your network? OK. Storage. You are there? OK, you are there. OK, as you can see that this Longhorn cluster doesn't really have anything yet. But if I click on the backup, they should show up the same information as in the first one because they're pointing to the same backup store. As you can see that, yeah, we have just created 2 backups in this backup store. And one of them just created 2 minutes ago. And the last backup could create minutes ago because we said that, OK, create backup every minute. Not really that, you shouldn't be that aggressive in the production environment, but this is demo. So what we're going to do is, OK, which volume is this? I don't know. It's just a PVC plus random name. How can I know that which workload is using it? In fact, you can, after the network works. So you can see the label for each backup. OK. And you can see that the name is here. It's WordPress, because it's what used by the WordPress pod. And I'm going to create a disaster recovery volume, which is we are going to enable it later for the WordPress. All right, I think I just did. It's not this one, right? Yeah, this is right. So this one should be the MariaDB. We can confirm that. Yeah, it does say MariaDB. So we create the volume here in the second cluster, and we call it MySQL WordPress DB. OK, so now in the second cluster, you see 2 volumes has been created up, and they are basically get incremental restore from the backup. So anything I changed, for example, in this page, we are going to get automatic backup in that one. So I just add a new post here. So probably wait 1 minute and see, oh, somehow the WebSocket works now. OK, that's a relief. And this is the original cluster. As you can see, the volume name is totally randomized, randomly generated by the Kubernetes. Let's wait a few seconds for it to be restored. So yeah, I can take some questions now. I think I can wait 1 minute.
Yeah, let's actually table the questions.